Hello, everyone, and welcome to Safe Demos. I'll just start by giving a little overview of what this channel is, just because this is my first introductory video. So, essentially, what I'm aiming to do is to create a channel where we dive into cool, hands on cybersecurity projects, walkthroughs, and just interesting experiments. So, whether you're just getting started or if you're already in the cybersecurity game, this channel is all about showing real setups, real tools, and real results. Um, so in this first video, we're going to kick things off by building our foundational home lab. So I'll be using VirtualBox and a couple of virtual machines to simulate an isolated internal network. Um, Essentially, this lab will be the heart of everything that we do going forward. So whether it's from running attacks, building defenses, capturing logs, and just showing you exactly how, I guess, stuff work behind the scenes. So if you're into practical cybersecurity and are a hands-on learner, then I believe that you're in the right place. Um, so yeah, just a little bit of background about me now. Now that we've gone over what the attention for this channel is, I'm currently a cybersecurity student. I would say my skills are not up there in any way. I'm still, I guess, getting my foot into the water. I'm not too advanced when it comes to pen testing, and I guess I'm just trying to learn along the way. And the reason why I'm starting this video off with a dedicated home lab is because I've noticed within my, I guess, educational journey, I was always assigned to create virtual environments and network topologies for specific assignments and projects. But I've recently realized I've never created one just for myself for, I guess, personal use and just uh, for little side projects or just playing around with. So I think that's something that is kind of crucial to have, especially for independent learning. So yeah, that's what we're going to do today. Now let's actually take a look at what our network topology that we will be setting up today looks like. So it's nothing crazy. It's very simple. We'll have one router that acts as a gateway that has external connectivity. And it will also act as a switch just because you can't really do that within VirtualBox. And I guess a router VM will actually play the role of a switch just in this virtual environment. Essentially, so there is an internal network as well. So within this internal network, we have an attacker VM, which will be Kali. We will have a logger VM, which will probably load up an ELK stack on there using that's Elasticsearch. We'll most likely be using Ubuntu desktop for this. And finally, we will have a target VM, which will be like in Ubuntu server, and I'm not exactly sure what we'll set up on there just yet. Maybe we'll do WebGoat, um, but that's something we can just, I guess, decide later on. As of right now, we're just focusing on the actual main setup right now. So we'll start off by actually getting the appropriate network connectivity. So the way that that will happen is I'll just show you the IP assignments that I have in mind. So for our internal network, we'll be using the subnet 192.168.83.0 with the prefix of 24. And if we take a look here, the router that's also acting as a gateway will have two network adapters. One which is NAT, which is automatically assigned by VirtualBox, and a second one which will be connected into the internal network. So we'll assign that with the first usable IP, which is 192.168.83.1, and this will act as a gateway for the internal network. Um, and then you can see that the rest of the VMs all just have one singular network adapter, and that will be an internal adapter in VirtualBox. Um, and these are the IP assignments for them. Um, so also what we'll be doing is we'll be enabling port forwarding. That way, the router VM actually shares internet connectivity with the internal subnet, And yeah, so that allows the internal VMs to reach external connectivity. I do apologize if my wording is very redundant. I'm fairly new at this, so bear with me. Okay, so let's open up VirtualBox now. As you can tell, I'm running this on a Linux operating system. I do have these VMs saved on an external SSD, and I can essentially change between whether I want to use my Windows operating system or my Linux one. So I find that when it comes to running VMs, the Linux machine does a very good job, less lags, less crashes compared to my Windows PC. So as of right now, I went ahead and just saved us a little time in this video. I installed all of the operating systems. However, I have not configured them. So you can see that all of them currently have NAT adapters. That's just because I literally just installed the operating system and that's it. I have not even logged on yet. So we'll be doing the configuration of this together. Um, and I guess we can start off with the backbone of this network. We'll start off with the router VM. So let's log in now. And I guess the first thing that we'll do is just take a look at the network adapter. We can see we only have the NAT adapter right now. So I guess let's just power this off really quickly. Let's go into network settings. We'll add a second adapter. After we enable it, we want to select internal network. So you can either name yours. Actually, I'll just name mine for sake of demonstration. We'll do home lab. Yeah, I'll just keep it as home lab. Let's go ahead and do that. Let's power back on. And in the meantime, I should probably do the same thing here. So I'll just power this off for the target, just to speed things along. I'll keep the same first network adapter. I'll just change it from NAT to internal, and we can see that home lab has been prompted up. If we choose I guess it's the only one available, but you want to make sure if you do have different ones that you're on the specified, I guess, local area network that you want, or else your VMs will not be able to communicate on that internal network. So let's go back to the router VM. So let's log back in and let's run that IP-BR8. Again, we can see that now we do have a second network interface. However, the status of it is down. So what we'll do is we'll use NetPlan in order to configure this. So you'll just do, I use Vim, okay? Don't come for me. I like Vim. I find it very straightforward. Apparently, a lot of people don't like to use this as a text editor. They prefer other tools like Nano, but I personally love it. So I usually just go into the default, I guess, template that's already there in NetPlan, and I just change out, I guess, any necessary information I need to change. So I already have it memorized. Um, However, if you, I guess, are trying to avoid those, I guess, picky syntax errors, I can show you how you would find it. You can just do cd into the directory of NetPlan and just simply run an ls command. You can see that that is the official, I guess, the default um, uh, configuration file that's in there. So I'll just do sudo vim 50. I don't have to specify the path because I'm already in this directory. So we'll just do 50 cloud dash dot YAML. So no, let me just put that in. Perfect. So this is the default, I guess, configuration file. We'll just go ahead and make our edits. I'll add render network D, version 2 Ethernet. So this is the router. we'll keep this the way it is for the first adapter. However, for the target one, because we simply enabled, I guess you can't really, we won't have access to change it, but in the network tab, we used the first one. So for when we're configuring the target, we can actually just switch out this first Ethernet adapter's configurations. But in this case, we'll go ahead and add an additional one here. So you have to remember the name of your interface. And also just keep in mind that the index does, I guess, the placement of your inputs do matter, or else you'll get some error messages when you're trying to run sudo netbind apply. Anyways, let's go ahead and do this. DHCP4, we'll set this as no because we're going to put a static IP, and the static address will be, if I'm not mistaken, it is 192.168.83.1. Yeah, so we'll go ahead and do that. And we'll have to specify the prefix there. So this should work, if I'm not mistaken. Yeah, I'm just double checking. Sometimes it is a little weird. Let's see if I'm getting any issues. Perfect, we didn't. So now if we run the ip-bra command, we can see that I do have a static IP assigned on the second internal adapter, and it is our specified one, which is 192.168.83.1. So now that we've set up a static IP, the next step would be to enable routing and NAT. So we can either, I guess the easiest way I'd say is let's just go back to our home directory, and we'll want to sudo into the actual file path for, I believe it's sysctl.conf, and perfect. We'll go ahead and uncomment this line here. It says uncomment the next line to enable packet forwarding, and that is exactly what we want to do here. So we'll go ahead and just uncomment that, save the file, and that is it. So if we want to, I guess, see if it took to effect, I believe we can do sysctl-p if I'm not mistaken. Oh, okay, I gotta do sudo. And we should get return the value of 1. Perfect, that means it is uncommented. And I guess now we need to enable NAT. I know the standard is, I believe, iptables now, but I'll just use iptables. It's very straightforward. I'll just do sudo iptables -t nat -a post routing -o p0s3 -j masquerade. So essentially what this does is just, if I'm not mistaken, this just tells the router to hide or masquerade the internal IP addresses of the devices in the internal network when they are reaching, I guess, the external, I guess, when they're essentially leaving the router. So we'll go ahead and do that. And now the next command that we'll run will be what actually gives us that internet connectivity within the internal network. So we're essentially forwarding the traffic from the internal subnet into through the router. So without this, then the internal VMs will not have internet connectivity. So we'll go ahead and run that. And what I like to do is just make this persistent so we don't have to do this. If you don't save these firewall rules, then it will essentially just wipe away once you reboot your system. So it's nice to install iptables persistent. Um, persistent. We'll go ahead and install that really quickly. All right, so we'll go ahead and save our current rules. Perfect. So we can see that it will automatically be enabled during the next system startup, which is exactly what we want. So now that that's done, I believe that's all that we need to do for this VM. Let's move on to, I believe the attacker VM is next. Actually, I should have set this up previously. So I installed a pre-installed uh, or pre-built VM for Kali, just because previously I used to have issues with installing Kali through an ISO image. I just have horrible luck, so ever since then I've just been using these. So I'll just go ahead and create a user really quickly. Let's see if I can sudo. Perfect, I can. All right, so what do we want to do here? So now that I've added my user, this has an NAT adapter. We'll go ahead and shut this off, change that to an internal adapter, and we'll get the party started. Actually, let me just make sure Vim is installed. I think it already should. All right, perfect. So yeah, the little word of advice, if you have specific packages that you want to install before, I guess, getting your network set up and changing it from a NAT adapter to an internal, do that really quickly beforehand and I guess move on to the next step. So in the meantime, um, we'll work on, I guess, we'll do the target for now. So the target VM should be, if I'm not mistaken, 0.30 as the last octet of the IP. Let me just see here. All right, so we'll do the same thing. You can see that I believe there's no IP assignment. It's down. Oh, I guess it is up. However, there's no static IP assigned. So we'll do sudo vim netplan and we'll go to that default configuration file and we'll make our necessary changes. So we'll do render network D and then we'll set DHCP to no addresses. We want to specify 192.168.83.30 and don't forget the prefix. I believe this should work. Let's go ahead and save this. Oh, actually, we need to add a route here. So we can just do routes and then to default via, and then we want to put the internal IP address of the router VM, which is 83.1. And in this case, we don't have to specify the prefix because we've already done that for an actual address. So we can go ahead and close this file, save our changes. Let's run sudo netplan apply. Perfect. Let's IP-BRA. Perfect. We can see that. Let's go IP route. We can see that as well. So a good indicator, this is, can we ping our router VM? So let's go ahead and test that out. Let's send that. Perfect. We can see that there's connectivity there. We'll do the same thing for our attacker VM. We'll set that up. In the meantime, actually, we already did the, if I'm not mistaken, we did the packet forwarding and NAT enabling already. So we should actually be able to ping Google. Let's see. Perfect. So we have internet connectivity that confirms it. Let's see if we can actually ping google.com. This might not work. So a temporary fix for this, you just go sudo vim etc/resolve.conf. Get that in. Just change this to 8.8.8. Save that. Run the ping command again. You can see that it works. All right, wonderful. So let's move on to this here. We'll log in. Let's go here. Personally, I don't like a see-through background. Let me just change that really quickly. All right, so let's go sudo vim /etc/network. I believe it's interfaces. All right, so we'll change this ETH0. .10 is this one, net mask. And then we want to specify our gateway is 192.168.83.1. So let's go ahead and save that. Let's just make sure that that is the correct interface name. It is. All right. So now we want to do systems, sudo systemctl restart networking. Now that that's done, let's check our IPs. It's assigned perfect. Let's check IP route. Goes to our default gateway, which is good. Let's ping 192.168.83.1. Successful ping, which is great to hear. And let's try the target VM. You can see that we can reach out to that as well. Let's ping Google now. Ping. Interesting. Not sure why that is. Oh, did our route disappear? Okay, sudo. Huh. Not sure what's going on here. Let's. All right. Let's. All right. That was odd. Okay, we're able to ping that. Let's see, ping google.com. And we are able to ping Google as well, which is good. So we have target set up, can ping Google, attacker, same thing. Now let's do log server really quickly. So I have yet to actually log on and configure anything here. So yeah, as expected, we have these pop-ups. We'll just skip these for now. And let's go ahead and see if we have our IP. Yeah, it's currently as NAT, most likely. What do I want to check here? Let me see if I have Vim. No, I don't. So I'll just quickly do sudo apt update. Upgrade any upgradable packages. This might take a while. we'll just skip to this is completed. Okay, so now that the upgrade is done, let's see if we have Vim. We still don't have Vim, so I'll just do install Vim. Now that I have my lifeline, let's go ahead and power this off. Let's go to network settings. Just switch this from NAT to internal, and that will be our home lab. Perfect. Let's power this back on. And this should be very quick. All we need to do is set a static IP, set a route, and we should be able to communicate with all devices on the network and also reach external connectivity. The reason I like this setup is because if we do require I guess, any scanning or anything that shouldn't be done while exposed to an external network, all we need to do is just either shut off the router VM in total or just set the internal adapter that it has as down, and there's no external connectivity for our devices in the internal subnet. So it is a good way to ensure a controlled testing environment. So let's go ahead and set this up. Personally, I find that Ubuntu desktop is the one I have the most issues with when it comes to lagging and crashing. Hopefully that won't happen to us here. But anyways, we'll go ahead and start by double checking that we have that second adapter there, or that first adapter in this case. We can see there's no IP assignment. We'll go ahead and rectify that. So we'll go ahead and change these. Network D, and then we'll change this to no addresses. We'll specify 192.168.83.20/24, and then we want this to route to our default gateway, which is the router in this case, to and we'll put in our IP, and that should work. Sudo netplan apply IP-BRA. Although we are getting a few error messages, we can see that the IP has been assigned. We can go ahead and try see our IP route. Perfect. It's going to the gateway, so we'll go ahead and ping 3.1. That's a successful ping. Let's see if we can ping the attacker VM. We're getting successful ping there. Let's see if we can ping our target VM. Successful ping as well. Let's see if we can do Google. We can. And finally, I'll just go ahead sudo vim /resolve.conf and just make sure we can ping google.com. That's a successful ping as well. So now we'll just go ahead and just make sure that we can indeed ping this log server now. So we can see that the target can ping it. Same thing for the attacker. Well, it should at least. So go ahead and try that. Successful ping. And obviously this can ping it as well. So let's just go through our checklist right now for this video. We can see that all devices can ping the gateway, so we can cross that off. Kali can ping the log server and the target, we've confirmed that. The log server can ping the attacker and the target, and the target can ping the attacker and log server. Finally, router can access internet. Obviously, we know that that's the case because it is sending or routing internet connectivity over to the internal devices. So that just confirms that. And let's go back to, just give me a second here, our checklist. Um, and finally, all internal devices can access the internet, so we can cross that off. And since that is the final thing on our list, we've now got our home lab topology built. The network is up and the router is configured to get everything talking. So I believe in the next video, we'll start assigning real roles to each device. So we have the attacker, the target, and the log server. So we'll go ahead and install the tools and services needed to actually bring this lab to life. Make sure to follow along the journey, and I hope to see you along the way.